All right, here we go. 10, 9, 19. Okay, so we're talking about simplifying cube roots, fourth roots, etc., etc. Cube roots, fourth roots, fifth roots, whole bit. So before I even start, let's write down some numbers, okay? Let's write down the n cubed numbers. And we wrote these down yesterday. In fact, they're still here, but I want to write them down again because these are the numbers we want to find today. And, you know, most kids don't know these, which is okay. You don't need to know them. Just write them down so you have, okay? So 1 cubed is 1, right? 2 cubed is 8. 3 cubed is 27. 4 cubed, yep. 125. 216. 7 is 343. Is a 512. 729. And then 1000, okay? All right, good. And then we'll put down the force after that. So, and we don't need a lot of the force, but we'll put down the force into the fourth. Into the fourth will go a 1. 2 times 16. 3 times 3 times 81. 4 times 4 times 4 times 4 is 256, I think. I could be wrong, though. Hold on. I think it's 256. 4 to the fourth is, yep, 256. 625. And I highly doubt if we'd need it bigger than that, but we'll try it anyway. 6 to the fourth is, yeah, 1,926. And I highly doubt if the book or any of this would put that in there, but there it is. So what are these numbers? Yeah.
Perfect.
Perfect cubes. Cube root of 8, 2. Cube root of 27, 3, right? Cube root of 64, 4. Cube root of 125, 5. You guys got it?
6.
Yeah. So if we take a look at example 1, that's not a perfect cube, but one of these numbers might be a multiple of it, right?
So
It's 27. How'd you come with 27 so quickly? Yes.
this is 54 divided by 670.
Yeah, so you did it in your head. So if you're unsure, watch. You've got calculator, right? You know it's a cube. You know you can need one of these. I think the 27 was a good guess. Do you guys agree that 27 was probably a good guess? So try it. Say, okay, what's 54 divided by 27? Does it go in evenly? Does it go in evenly? Yes, it goes in evenly, right? So let's rewrite this whole thing as the cube root of 27 times the cube root of 2. And then we're going to just do the same process we did with square roots, except for its cube roots. We know the cube root of 27 is a 3. Plain old 3, right? Plain old 3 times the cube root of 2. Thumbs up? And the cube root of 2, we leave as cube root of 2 because it's a really ugly decimal number, and we'd rather write that instead of the ugly decimal number. Thumbs up? Okay. Example 2. It's a fourth root of 48. Okay, so what I want is I want to find one of these numbers in it. What do you think? One of these numbers. What do you think? Well, it can't be anything bigger than that. 16, probably 16, right? So if we're not sure, again, if I'm like, I don't know, golly, I think it's 16. Just try it. What is 48 divided by 16? If it goes in evenly, we're going to use it. Sure enough, right? So let's go the fourth root of 16 times the fourth root of 3. And the fourth root of 16 is not 4, it's 2, right? It's 2. So we get a 2 times the fourth root of 3. How's that? All right, example 3. All right, can I reduce this? Maybe a little bit. I mean, it's 640, so I might be able to reduce that a little bit. Let's reduce first, and let's make it the cube root of 3 over the cube root of 20. Okay with that? right? And now, what else can I do with that? Well, if it's a cube root of 20, I don't know if any of those numbers are in there. Oh, you know what? I might have done this a harder way. Yeah, because I could have done 85 instead. Now left with a 20, right? Times 4, maybe not. Maybe not. Let me keep going with this. We'll just keep with a half. Okay, you ready? This is the same thing as a cube root of 3 times a cube root of 5 times the cube root of 4. Not really helping you a whole lot, am I?
That didn't help at all.
Well, kind of did, but it kind of didn't.
I don't get it.
Yeah, Seth, I totally understand. I get it, but I'm definitely taking the hardest way to solve this, okay? A little whiteout. You guys mind if I get some whiteout? Seth, this problem is doable, but there's an easier way, so sorry. I picked the hardest way to do it. My bad. Let's go back and do an easier way to do it, okay?
So you know what we do, sit down.
You want to see an easier way to do it?
Yes, please.
Yeah, definitely, okay. All right, a little whiteout. Let's try an easier way. There is hard ways to do math and easier. Let's always pick the easier way, okay? All right, now. 2 and... Okay, how about this? How about this? You ready? Cube root of 6 over the cube root of 5 times the cube root of 8. All right. Hopefully this is going to seem easier. Okay, cube root of 8. Cube root of 8 is what? 2. So we got something. You guys agree? I got 2. Okay. Seem easier, Seth, now? So let's change that to a cube root of 6 over 2 times the cube root of 5. Okay, how am I doing? Is that better? Okay, now, if we're going to clear the root in the bottom, we're stuck with this. The rule is you can't have it, right? I got to make this number into one of these. Can I make the 5 into one of these?
25.
Yeah, 125. So if I multiply by 25, it'll make 125, and there is a cube root of 125. Okay, good. You do see that, don't you? Okay, so now let's go ahead and say, all right, I'm going to multiply this by cube root of 25, because our goal is to make 125, right? Cube root of 25. Okay, so let's see what happens. So I'm going to get the cube root of 125 over 2 times the cube root of 125. Wow, that cancels, doesn't it?
What?
Oh, 150. 150. My bad. Cube root of 125 is 5. I'm going to scoot this over here. So I'm going to get the cube root of 150 over 2 times 5, which is 10. Wow, this is not an easy problem, is it?
How do you get the 5?
Do you need 150 on top?
Yeah, why do I keep putting... Yeah.
Is that your final answer?
That's your final answer. Yeah, that's not a very nice problem, is it?
Isn't it just a little bit on that?
That is not a nice problem. Wow. Okay.
Wait, no, it's called
125, 150 divided by... Nope. 8?
This is something to ask.
Nope. That's it. That's got to be the only answer. Oh, that's a bad answer, huh? Okay, what number is that going to make? That's going to make 125, right? Which is a perfect cube. Let's do the next one and see if it gets easier, okay? I see something example 4. Do you guys see anything example 4 at all? 81. Okay, I see 81. 81 is perfect cube root. 81 is one of these, right? It's perfect cube. No, it's perfect fourth. It's a perfect fourth. I go back up to here. 81 is perfect fourth, right? Let's go down. Oh man, these are hard. So fourth root of 10 over the fourth root of 2 times the fourth root of 81. Okay. Oh, this one isn't too bad. This one's not too bad. Because I'm going to divide that, because they're both fourth roots. So I'm going to divide that and get a fourth root of 5 on the top. You okay with that?
Wait, why don't we divide those two?
Well, it's going to be, let me rewrite it. Like I could have rewritten it like this. Big fourth root of 10 over 2, which is what? 5, right? So let's just go straight to the fourth root of 5. And then over 3. Over 3, because 3 times 3 times 3 times 3. These are hard, aren't they? I don't think I have a whole lot of these on your test. Over. Yeah. Yeah. Okay. All right, want to do something easier now? Let's go back to square roots, huh? Back to square roots. So if I go back to square roots. Okay, example 5. What do you see on example 5? The conjugate. What's the conjugate?
Square root of 3 minus 2.
Yeah, smart girl. Totally agree. Because it will cancel it out in the bottom. It really will. So you ready? That times that, that times that. 5 square root of 3 minus 10 over the square root of 9 minus 2 square root of 3 plus 2 square root of 3 minus 4. Cancel, cancel, right? Square root of 9 is a 3. Let's see what I get. 5 square roots of 3 minus 10 over negative 1, which is okay, but I like this answer better. I just divide everything by negative 1. You okay with that? Was that easier? A little bit easier. These cube roots are hard, huh? Okay, turn the page. Let's see, that was just bad anyway. Okay, turn the page and example 6. What do you think? The conjugate, right? It's still the conjugate. We're going to multiply by the square root of 5 plus the square root of 3 over square root of 5 plus the square root of 3, right? Let's go. 3 times square root of 5 is 3 square roots of 5 plus 3 square roots of 3. Okay? 3 square roots of 5 plus 3 square roots of 3 over the square root of 25 plus the square root of 15. Lily, you're supposed to catch my dumb mistakes. Lily, I depend on you to find my dumb mistakes. There you go. Okay. Minus the square root of 15 minus the square root of 9.
Wait, so it's 3 square roots of 5 minus 3 square roots of 3.
Yeah, I had to have minus because that's the conjugate. Seth is the opposite of that, right?
Right.
Yeah. I know what I'm doing. I just keep making mistakes. Right? I really do. Okay, so then I get 3 square roots of 5 minus 3 square roots of 3 on top, and that becomes a 5, and that becomes a 3. 5 minus 3 is a 2, so all over 2. Okay, now if I stop making mistakes, it's going to be a lot better, right?
People catch them and then
Okay. All right. This one's not bad. So we can't add them unless they're the same. So 375, what do you think? 375, where's our number? 375, 125, you guys get that? So in fact over here, 375, probably 125, right? Something times 125. And again, if we're not sure, we just use a calculator. Okay, well, I don't know. The question is 375 divisible by 125? And the answer is yes. It goes in evenly 3 times, okay? Cool. Okay, I checked it. So let's rewrite this. 3 times the cube root of 3 minus 5 times the cube root of 125 times the cube root of 3, okay? That's 5, right? 3 times the cube root of 3 minus 5 times another 5 times the cube root of 3, because the cube root of 125 is 5, because 5 times 5 times 5, okay? So 3 cube roots of 3 minus 25 cube roots of 3. Now I can subtract them, right? Negative 22 cube roots of 3. Bam! Sorry for the dumb mistakes. It happens.